Hello and welcome to my new Geometry Notes notary. It's called Space Instances Evenly, and that's exactly what it does. So as you can see here, you have here a collection, and the collection has just some objects, and as you can see, a bolt, round cube, Suzanne, T-joint, and twisted toast, and this takes it as input parameter. And then here you have the spacing, that's the space between the objects. And you can change here the animation offset, so you can animate the movement if you want to. Then you have count. I think that's self-explanatory. It's the number of objects you want to see on the curve. And the text width, we take another one. This is here, a new one. And here you see the text space width, so it's the space of the text which it should take. New file, just hit A, X, delete everything. Shift A, curve, circle S, 20, Control A, apply scale. And now we go to Geometry Notes. We now need some objects, so let's do this. Shift A, mesh cube, and then hit M, new collections. We call this objects, create. Shift A, mesh cylinder, S2, Control A, apply scale. And if we cleverly select now here this collection, new objects will automatically go in this collection. Shift A, mesh toes, S3, Control A, scale, and one more. Shift A, mesh UV sphere, S4, Control A, scale, just that we have some objects with different sizes. Now, new geometry node. So now, how do we do this? We will use a sample curve node, and we will use this sample curve node with length. What does it do? It spits out here the position if you put the length here. So if you use this example given with a cube on position 0, it will position this here. And this is not what we want, because if we now have another cube and we want to space them evenly, then this would be the position here we have to calculate. Okay, the half length of the first object here plus half length of the second object there. This is complicated shit. I don't want to do this. I thought about a better method, and the better method is if Blender creates an object, the pivot point is 0, and you have some vertices on the negative x-axis and some vertices on the positive x-axis. So if you move that cube on just the positive x-axis like this, then this here will look different and it will make the calculation much easier. Because at 0 now, because we moved the mesh and we rotate it right, then this is the way it looks. So we can just say here 0 and the first cube would stand there. And if we now have another cube, its position is just exactly the width of the x. So just this value. And this is very easy to calculate. And the position of the third is just x from the first plus x from the second. And this is exactly what we want to have. You have an easy calculation, an easy node tree. That's what we want to do. So first of all, we move all meshes so that there are positive x values. How do we do this? We add a collection info node. We choose here the objects, and now you see we have here just one instance. That's why we separate children, and now we have 4 instances as we want to have it. And we use now this new instance in bounce node, and then we say set position, and then from the instance bounce node we use vector mass multiply, not subtract. We use multiply multiply for the vector math, and we multiply the minimum value with minus x, and then we get, you see here, minus x and plus x, and now we plug this in. All values now are positive, all x values. It's exactly what we want, so we call this move meshes to positive x to have easier calculations. So these are now our cool meshes. What we need now is the width, the x width of every mesh. This is also a case a case where we use the instant bounce. Now we subtract vector math. This is here, this is just max minus min. And then we separate x, y, z. And then we got here our width. So we call this width x. Wait, so this is our x width. That's great. This now must come in here, but that's not right, but we will correct this. And the curve, of course, comes from here. And what we want to do, we want to make here points on that circle and then instance the objects on it. So we have to create points. How many points can decide the user here? And then we just increase the size here. And these points we have to move on the right positions. And the position, of course, comes here from the sample curve node. And on these points, we want to these moved meshes here, of course, and the position is here, and then we say join geometry to see something, and here we are. So everything is here, which is not good because we just use the widths, but we don't accumulate the widths, and we have to sample it over to the right domain. So we say sample index. The domain is instance because, and the width is coming from here. And then we do this here and index, which is in this case the instance index. So we want to pick the instance, and here we are. And now we have to, because this is only one value, we have to accumulate the values, float point, this is right, and don't use leading, we use trailing. So this is the basis of the thing, but we have the wrong rotation. We have to repair that as well. So we use here this rotation value. And we do this with axis to rotation. We use x and y, and we use here the tangent for the primary and the normal for the secondary. And watch this, we have already, let me hide the annotation here. We have already the first result. You see here there is a double because we have count 45, but the index is never bigger than the number of the inside the collection. So we have to repair this. So we get a domain size, and the domain size is of the instances. And then we use this very funny modulo trick, modulo, and the modulo by the instance count. Why does this work? Because let's say we have, what do we have? We have 4 instances, and the modulo makes out of it 0 to 3. 1, 2, 3. And again, and again, and again. And by this, here the instance will never be over 4. That's why this works. Why do we have here that problem? Because the sample curve is now overshooting, and we have to reduce then here the count. So this is what I wanted to show you. This is the basic node setup. Now we can make this even a little bit better because if you watch closely, see that the rotation is not perfect because it takes this rotation amount, but it should take this one in the middle. Then the alignment of the object or the rotation would look better. So let's do this. So we need another sample curve node. And this sample curve node, we don't want to use this value or this, but we add the half of the actual object. And then we can, from there, take the rotation value. So we need, of course, the same curve, but we add from the actual value, the value of the current width, which is this, but just the half. So we divide by 2. And this is our length. And now, instead of taking this tangent, we take that tangent and that normal. And if we now watch the difference, we just make here a vector, and we take the rotation here, and from the old one, I just want to show you that you see the improvement. And if I switch now here, you see this is the better rotation, because that's a new case, and this is the worse one because everything is too far outside, and this is a better one. That's what I wanted to show you. Of course, you can improve it even more, and my SuperHive version has some more fields which you can improve here, but I think you can easily do this yourself. I hope you like it. If you learned something, have fun.